I've been building computing systems for over 30 years. I've seen the rise of graphics processing, the birth of parallel computing, and the explosion of artificial intelligence. But what's happening right now is different from anything I've witnessed in my entire career. We're not just experiencing another technology cycle. We're witnessing the most profound transformation in human history, and it's accelerating at a pace that even I find breathtaking. The course of history has just changed, and I'm going to show you exactly why. Let me start with something that should fundamentally alter how you think about the future. 3 months ago, I stood on stage and told the world that we had entered the age of artificial intelligence. I said that AI would transform every industry, every company, every job. Some people thought I was being hyperbolic. They thought this was just another tech hype cycle, like the dot-com boom or the blockchain craze. But here's what's actually happened since then. The rate of improvement in AI capabilities has not just continued, it has accelerated. We are now seeing AI models that can reason, that can plan, that can solve problems we didn't think machines could handle for decades. And the gap between what AI can do today and what it could do just 6 months ago is wider than the gap between 6 months ago and the entire previous decade. This is not linear progress. This is exponential progress. And most people, even very smart people in technology, are dramatically underestimating what this means. Let me give you a concrete example. 2 years ago, if you wanted to generate an image using AI, you would get something that looked vaguely related to your prompt, but clearly artificial. The hands would be wrong, the faces would be distorted, the details would be nonsensical. It was impressive as a technology demonstration, but not useful for real work. Today, AI can generate images that are indistinguishable from photographs. It can create videos that look like they were shot by professional cinematographers. It can design products, write code, compose music, and solve complex mathematical problems. And this transformation happened in just 24 months. Now, I want you to think about what that rate of progress means for the next 24 months. If we improve this much in 2 years, where will we be in 2 more years? Where will we be in 5 years? Where will we be in 10 years? The answer is that AI will be capable of doing essentially any intellectual task that humans can do. And it will do these tasks faster, cheaper, and in many cases better than humans. This is not science fiction. This is the clear trajectory we're on right now. At NVIDIA, we've been preparing for this moment for 15 years. When I made the decision to pivot our company from just graphics into general purpose GPU computing, a lot of people thought I was making a mistake. Graphics cards were a profitable business. Why risk it by going into a market that didn't really exist yet? But I could see where computing was heading. I could see that the future wouldn't be about faster individual processors. It would be about massive parallelism. It would be about doing thousands or millions of calculations simultaneously instead of one at a time. And I could see that this type of computing would be essential for the next wave of technological innovation. That bet has paid off in ways that even I didn't fully anticipate. NVIDIA's market capitalization has grown from about $10 billion 15 years ago to over $2 trillion today. We've become one of the most valuable companies in the world. But more importantly, we built the infrastructure that's powering the AI revolution. Every major AI breakthrough of the last 5 years has been powered by NVIDIA GPUs. GPT-3, GPT-4, Claude, Gemini, all the large language models that are transforming how we interact with computers, they all trained on our hardware. The image generation models, the video generation models, the protein folding models, the autonomous driving systems, all running on NVIDIA technology. But here's what most people don't understand. We're not just selling hardware. We're not just a chip company. We're building the computing platform for the age of AI. And that platform is becoming as fundamental to the economy as electricity or the internet. Think about it this way. In the early 1900s, when electricity was being rolled out across America, every factory had to be rewired. Every business had to figure out how to use electric power. The companies that helped with that transition, companies like General Electric, became some of the most powerful corporations in history. The internet created a similar transformation in the late 1990s and early 2000s. Every business had to get online. Every company needed websites, servers, networking equipment. The companies that provided that infrastructure, companies like Cisco, became enormously valuable. Now we're at the beginning of the AI transformation. And just like every factory needed electricity and every business needed internet, every company is going to need AI infrastructure. They're going to need the computing power to train models, to run inference, to process the enormous amounts of data that AI requires. And this is where things get really interesting. The demand for AI computing is so large, so fundamental, that it's creating an entirely new category of economic activity. We call it AI factories. These are massive data centers filled with tens of thousands or hundreds of thousands of GPUs, all working together to train and run AI models. Companies are investing hundreds of billions of dollars in building these AI factories. Microsoft is spending over $50 billion on AI infrastructure this year alone. Amazon, Google, Meta, they're all investing similar amounts. And it's not just the big tech companies. Every major corporation in every industry is realizing they need to build AI capabilities. This level of investment is unprecedented. It's comparable to the build out of the railroad network in the 1800s or the interstate highway system in the mid-20th century. We're building fundamental infrastructure that will power economic activity for decades to come. But there's something even more profound happening beneath the surface. The nature of computing itself is changing. For the last 60 years, since the invention of the integrated circuit, computing has been about making individual processors faster. Every year, chips would get faster because the transistors would get smaller. This was Moore's law, the observation that computing power doubled every 18 to 24 months, but Moore's law is ending. We're reaching the physical limits of how small we can make transistors. The latest chips have features measured in nanometers, just a few, atoms wide. We can't go much smaller without running into quantum effects that make the transistors unreliable. For a lot of people in the industry, this was terrifying. If we can't make individual processors faster, how do we keep improving computing performance? How do we keep the technology revolution going? The answer is what I've been working on for the last 15 years. Instead of making one processor faster, we make thousands of processors work together. Instead of serial computing, we do parallel computing. And instead of general purpose CPUs, we use specialized accelerators like GPUs that are designed for specific types of calculations. This is why AI is happening now and not 10 years ago or 20 years ago. The algorithms for neural networks have existed since the 1980s. The mathematical foundations go back even further. What changed is that we finally have the computing power to train these models at scale. And that computing power comes from parallel processing on GPUs. But here's the thing that most people miss. This shift from CPUs to GPUs, from serial to parallel, from general purpose to specialized, this isn't just about AI. It's about the future of all computing. Every workload that matters, from scientific simulation to database processing to video encoding, everything is moving to accelerated computing. At our most recent conference, I showed how accelerated computing is now 1 million times more energy efficient than traditional CPU computing for AI workloads. 1 million times. That's not an incremental improvement. That's a complete transformation of the economics of computing. Think about what this means. If you're running an AI model on a traditional CPU, it might cost you $1 million in electricity. On our latest GPUs, that same workload costs $1. This isn't just about saving money, though that's important. It's about making things possible that were impossible before. When computing is 1 million times cheaper, you can do things you never dreamed of. You can train AI models on data sets that were too large to process. You can run simulations that would have taken years and hours. You can deploy AI applications at scales that transform entire industries. This is why I keep saying we're at an inflection point. The economics of computing have fundamentally changed. And when the economics change this dramatically, everything else changes too. Let me give you a specific example from an industry that might surprise you. Healthcare, medical research has traditionally been incredibly slow and expensive. Developing a new drug takes 10 to 15 years and costs billions of dollars. Most drug candidates fail. It's an extremely inefficient process. But now AI is transforming drug discovery. We can simulate how proteins fold, how molecules interact, how drugs will behave in the human body. What used to take years of laboratory experiments can now be done in weeks of computation. And the accuracy is getting better and better. Companies using AI for drug discovery are finding candidates that work better, have fewer side effects, and can be developed much faster. We're going to see a wave of new treatments for diseases that were previously incurable. And this is just beginning. Or look at manufacturing. Traditional factories are designed for making the same product over and over again. The equipment is specialized. The processes are optimized for volume. If you want to change what you're making, it's expensive and time consuming. But with AI and robotics, we can create factories that are much more flexible. Robots that can see and adapt to different situations, manufacturing processes that can be reconfigured quickly, quality control systems that catch defects before they become problems. The entire industrial economy is being reinvented. Transportation is another obvious example. Autonomous vehicles are coming, and they're coming faster than most people realize. The AI systems that power self-driving cars have to process enormous amounts of data in real time. They have to see the road, identify objects, predict what other vehicles and pedestrians will do, and make decisions instantly. This requires a massive amount of computing power in a small, energy-efficient package. And that's exactly what we've built. Our automotive platforms are already in millions of vehicles on the road today. And every major car manufacturer in the world is working with us to build the next generation of autonomous systems. But transportation isn't just about cars. It's about delivery robots, agricultural robots, warehouse robots, construction robots. Any machine that moves and interacts with the world needs AI to navigate and make decisions. And all of that requires the kind of computing power we're building. Now, I want to talk about something that I think is even more important than any specific application. The way we create software is fundamentally changing. For the last 60 years, since we started programming computers, software has been written by humans. Programmers sit down and type out instructions, line by line. They tell the computer exactly what to do in every situation. This process is slow, expensive, and error-prone. Even the best programmers make mistakes. And the complexity of modern software means that it's nearly impossible to anticipate every possible situation the program might encounter. But AI is changing this. Instead of writing explicit instructions, we can now train AI models on examples of what we want the software to do. The model learns the patterns and figures out the rules itself. This is a completely different paradigm for creating software, and the implications are staggering. We're going to see an explosion of new applications that would have been impossible to build the old way. Software that can understand natural language, that can see and interpret images, that can reason about complex situations. All of this becomes possible when you shift from programming to learning. At NVIDIA, we're not just building the hardware for this new world, we're building the entire software stack. We have CUDA, our parallel computing platform that makes it possible to write programs that run efficiently on GPUs. We have libraries for every major AI task, from training neural networks to running inference. We have tools that make it easier for developers to build and deploy AI applications. This software ecosystem is just as important as the hardware, maybe more important, because it's what enables millions of developers around the world to build the AI applications that will transform every industry. And we're also building AI models ourselves, models for generating images, for understanding speech, for controlling robots, for simulating physics. These models are trained on our hardware using our software, and then we make them available to anyone who wants to use them. This is what I mean when I say we're building a platform. We're not just selling chips. We're creating an entire ecosystem that makes it possible to build, deploy, and scale AI applications. And that ecosystem is becoming the foundation for the next generation of computing. Now, let me address something that I know a lot of people are worried about, the impact of AI on jobs. There's a lot of fear that AI will replace human workers, that it will create massive unemployment, that it will make people obsolete. I understand these concerns. Anytime there's a major technological transformation, there's disruption. The agricultural revolution moved people from farms to cities. The industrial revolution replaced craftsmen with factories. The computer revolution eliminated entire categories of clerical work. But history shows us that these transformations ultimately create more opportunities than they destroy. Yes, some jobs go away, but new jobs are created that we couldn't have imagined before. And the overall standard of living increases dramatically. I believe the same thing will happen with AI. Some tasks that are currently done by humans will be automated, but humans will shift to higher value work. Work that requires creativity, empathy, judgment, the kinds of things that humans are uniquely good at, and AI will make humans more productive. A designer with AI tools can create in minutes what used to take days. An engineer with AI assistance can solve problems that would have been impossible before. A doctor with AI diagnostics can help more patients and catch diseases earlier. This is why I'm so optimistic about the future. AI isn't replacing humans, it's augmenting us. It's giving us superpowers, and the people who learn to work with AI are going to have tremendous advantages over those who don't. But there's another aspect to this that I think is even more important. AI is going to democratize capabilities that used to be available only to large organizations. Right now, if you want to train a sophisticated AI model, you need access to massive computing resources. You need data scientists. You need engineers. It's expensive and difficult, but we're working to change that. We're building tools that make AI accessible to everyone. You'll be able to describe what you want in plain English, and the system will build the model for you. Small companies, individual developers, researchers in developing countries, everyone will have access to the same powerful AI capabilities that only tech giants have today. This democratization of technology is something I'm passionate about. I've seen how technology can level the playing field, how it can create opportunities for people regardless of where they're from or what resources they have, and AI is going to amplify this effect dramatically. Think about education. Right now, a student in a poor rural area has access to vastly inferior educational resources compared to a student in a wealthy urban area. But with AI tutors that can provide personalized instruction, that can adapt to each student's learning style, that can answer questions at any time of day or night, we can give every student in the world access to world-class education. Or think about healthcare in developing countries. Many places don't have enough doctors. People die from treatable diseases because they can't get to a medical facility, but AI diagnostic tools that run on smartphones could enable healthcare workers with minimal training to provide much better care. AI could help identify diseases early, recommend treatments, and save millions of lives. These are the kinds of transformations that get me excited, not just making things faster or cheaper, but fundamentally improving the human condition, solving problems that have plagued humanity for millennia. Now, I want to talk about something that's happening right now that most people aren't paying attention to. The entire structure of the technology industry is being reorganized around AI. Companies that were dominant in the previous era are being challenged. New companies are emerging. Power dynamics are shifting. For the last 20 years, the cloud computing giants, Amazon, Microsoft, Google, they've controlled the infrastructure of the internet. If you wanted to build a web application, you probably ran it on one of their platforms. They had the data centers, the networking, the expertise. But with AI, the game is changing. AI workloads are so computationally intensive that they need specialized infrastructure. The hyperscalers are building out AI-specific data centers with tens of thousands of GPUs, but they're not the only ones. AI native companies are building their own infrastructure. Countries are building sovereign AI capabilities. We're moving from a world where a few companies controlled computing infrastructure to a world where AI infrastructure is being built out across the entire economy. Every major company is becoming an AI company. Every government is investing in AI capabilities. The centralization of the cloud era is giving way to a more distributed model. This is creating enormous opportunities. New companies that figure out how to leverage AI effectively can compete with incumbents that are 100 times their size. Industries that seem stable and unchanging are being disrupted. The entire competitive landscape is being redrawn. At NVIDIA, we're seeing this firsthand. 5 years ago, most of our revenue came from gaming graphics cards for PCs and consoles. Today, the majority of our revenue comes from data center products for AI. We've transformed from a gaming hardware company into the infrastructure provider for the AI revolution, and we're not done. The next generation of AI is going to require even more computing power. Models are getting larger, training runs are getting longer, inference volumes are exploding as AI applications are deployed at scale. The demand for AI computing is growing exponentially, and we're scaling our products and our manufacturing to meet that demand. This is why we've been investing so heavily in research and development. Last year, we spent over $8 billion on R&D. This year, it will be even more. We're not just iterating on existing products, we're inventing entirely new types of computing systems. Our latest GPU architecture includes innovations that didn't exist 3 years ago. Transformer engines optimized specifically for the attention mechanisms that power large language models, FP8 precision for more efficient training, multi-instance GPU for better utilization, NVLink for faster communication between GPUs. Every generation brings fundamental innovations that enable things that weren't possible before. And we're not just focused on the hardware. We're building end-to-end systems, full data centers in a box, pre-configured, pre-tested, ready to deploy. You can order an entire AI factory from NVIDIA, and we'll have it up and running in weeks instead of months or years. This vertical integration, from chips to systems to software to AI models, this is what allows us to push the boundaries of what's possible. We're not just optimizing one piece of the stack. We're optimizing the entire stack together. Let me talk about energy for a moment, because this is something that concerns me and that we're working hard to address. AI workloads consume a lot of power. Training a large language model can use as much electricity as a small city uses in a day. This raises legitimate questions about sustainability and environmental impact. But here's what people need to understand. Yes, training AI models uses a lot of energy, but once trained, these models can replace processes that use far more energy. An AI-optimized supply chain can reduce transportation, fuel consumption. AI-designed materials can reduce manufacturing waste. AI-managed power grids can make renewable energy more viable. And we're constantly improving the energy efficiency of our hardware. Each generation of GPU provides more performance per watt. Our latest chips deliver twice the performance of the previous generation while using the same power. Over the next few years, we'll continue improving efficiency, making AI more sustainable. Moreover, AI is going to be crucial for solving climate change, climate modeling, weather prediction, renewable energy optimization, carbon capture technology. All of these benefit enormously from better computing. The energy we invest in building AI capabilities today will pay dividends in helping us address the climate crisis. Now, let me bring this all together and tell you what I think it means for the future. We are living through the most significant technological transformation in human history. The invention of writing, the printing press, the steam engine, electricity, the computer, the internet, these were all revolutionary technologies that changed civilization. AI is going to have a bigger impact than all of them combined. Within the next 10 years, AI will be integrated into every aspect of our lives. Your home will have AI assistants that manage your environment, order groceries, schedule appointments. Your car will drive itself. Your doctor will use AI to diagnose diseases and recommend treatments. Your kids will learn from AI tutors. Your entertainment will be personalized by AI. Companies will be transformed even more dramatically. Every employee will work with AI co-pilots that make them more productive. Every business process will be optimized by AI. Every product will have AI inside it. The companies that embrace this transformation will thrive. Those that resist will disappear. And it's going to happen fast, faster than most people expect. The pace of progress in AI is accelerating. What takes 5 years today will take 2 years tomorrow. The gap between the leaders and the laggards is going to widen rapidly. This is why the work we're doing at NVIDIA is so important. We're not just building products. We're building the foundation for the future, the infrastructure that will power the AI revolution, the tools that will enable millions of people to build AI applications, the technology that will transform every industry. I've spent my entire career building things that didn't exist before, creating markets where there were none, betting on visions of the future that most people thought were impossible. And I've learned that the most important thing is to see where technology is heading and to position yourself ahead of the curve. Right now, we're at that inflection point where the future is becoming clear. AI is not a maybe. It's not a possibility. It's a certainty. The question is not whether AI will transform the world. The question is how fast and who will lead the transformation. At NVIDIA, we're committed to being at the forefront of this revolution. We're going to continue investing in research, pushing the boundaries of what's possible, building the infrastructure that the world needs, because we believe that AI will ultimately be a force for good. It will solve problems we couldn't solve before. It will create opportunities we couldn't imagine before. It will make life better for billions of people around the world. The course of history has changed. The age of AI is here, and I truly believe that the best is yet to come. We're just at the beginning of this journey, and the destination is going to be extraordinary.